Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called 4-Player Crazy Pong by 99% Sneaky. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We also may not have digits may not repeat along the marked diagonals, so you cannot have a digit repeating along this diagonal here, nor a digit repeating along this diagonal here. Digits along purple lines form a consecutive set. This is otherwise known as Renban lines. And they must form a set of consecutive digits, essentially. So you could have something like, say, 2, 6, 4, 3, and 5 along this Renban, and this would be valid because they form a set of consecutive digits. You could not have something like 2, 7, 4, 3, 5 because those are no longer consecutive, right? 7's not consecutive with 2, 3, 4, and 5. And those are examples of how Renban lines work. A digit in a white circle must appear at least once in the 4 surrounding cells. So, for example, and these are known as quad circles. For example, if you have a quad circle here with an 8 in it, that means in the surrounding cells, the 4 surrounding cells around the circle, there must be an 8. And those are examples of how quad circles work. And finally, we have a digit in a gray circle is odd. So that means all of these digits are odd. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first thing well, a couple things that come out to me. We have 2 circles here, which means those are 2 odd digits. And they're in columns 1 and column 9. Where a Renban that is 6 in length is in both column 1 and column 9. So that tells me that the digits remaining in the Renban, you cannot have 2 odd digits. Well, for a 6-length Renban, what are the possibilities? 1 through 6, 2 through 7, 3 through 8, or 4 through 9. That means you're either missing 1 and 7 and 9 in the case of 1 through 6. Okay, this wasn't as helpful as I thought it would be. Never mind. It's 7 or 9. You're missing 1 or 9 in 2 through 8, 1 or 9 in 3 through 7, 1 or 9 in 3 through 8, and then 1 and 3 in 4 through 9. So that's not as helpful as I was thinking. Okay. So then, but we know we have to be missing. So the circles are all odd cells. So let's color them red. On a Renban, you have to have 3 evens and 3 odds to form a consecutive set, right? Again, like we had 1 through 6, 2 through 7, 3 through 8, and 4 through 9 as the possibilities. Each of them require 3 odd digits and 3 even digits. Therefore, this is even, this is even, so that is helpful. We don't know about these. It could be 3 evens and 2 odds, or two evens and 3 odds. We don't know. So the one thing that did come to my mind that I saw was in these quads here. There has to be a 1 surrounding this quad here, which means there's a 1 guaranteed in columns 2 and 3. And there must be a 1 surrounding this quad here, which means there is another 1 guaranteed to be in columns 2 and 3. And columns 2 and 3 can only contain 2 ones total, which means one must be here, and then the other must be here, which eliminates 1 in the rest of columns 2 and 3. Well, what does that mean? That means this cannot be 1 and 5 adding up to 6. It has to be 2 and 4. So this is both even, first of all. These cannot be 2 and 4. It's either 1, 8 or 3, 6 here. What else do we have? So this is 2 and 4 here. That means we are guaranteed. So this is even. Okay, so 1 through 6 would require this to be 8, but it can't be 8. Because we have to have in surrounding this quad must be 1 and 8, which eliminates 1 and 8 in the rest of the box. So this cannot be 1 or 8. It's 2, 4, or 6 here. Because of that, we know there's an 8 on this renban. So it's either 3 through 8 or 4 through 9. Right, because there's no other place for 8 to be in column 1. Right? It cannot be on the odd circles. Can't be in this even cell here, so it must be on the renban. So including an 8 on a 6-length renban, it's either 9 through 4 or 8 through 3. Which means we are guaranteed one of these cells in a circle must be 1. Also, we know guaranteed this has to be 2 then. Right? 3 through 8 does not have a 2. 4 through 9 does not have a 2. So this is 2, and this has to be either 1 and 9 or 1 and 3. And 1 cannot appear in box 7 because it has to be surrounding the quad clue here. So this one is either 3 or 9 here, and this is guaranteed to be a 1. Well, this 1 means 1 cannot appear anywhere else in this box. So where is the 1 surrounding this quad? It must be here. Oh, that's interesting. So this is 1, which means 1 cannot be here and 1 cannot be here. 1 must be on this renban, which means this renban is 1 through 6. Right? Because you have to have a 1 on this renban. The only one that has 6 digits that works is 1 through 6. So then this must be 8. And this has to be a 7-9 pair. And this 7-9 pair, this one sees this because of the diagonal, and this cell sees this by normal Sudoku in the same row. So 7 and 9 eliminate 9 from being there. So this is 3, which means this must be, that's 3 in the corner. We celebrate because we're getting closer to solving this. This must be 4 through 9 here. This cannot be 4 because of the 2-4 pair in the box. This can't be 8 because of the 1-8 pair in the box. So, this is a 5-length renban, and it cannot have 3. That means it's either 4 through 8 or 5 through 9. Either way, it has to have a 7 in it, and this can't be 7, so this must be 9, which makes this not 9, that's 7. So again, this has to be 4 through 8 on this renban. And we have to have 1 and 2 remaining in row 9. This can't be 2 because of 2 in the box. So this is 1, which makes this 2. That eliminates 2 in the rest of that box. So this can't be 2. This is even. This is odd. Okay. This is 1 here, which eliminates 1 here. So therefore, this is the 1 here. This also eliminates 1 here. This is a 5-length renban, and we can't have 8 and 9 on it because we don't have 1 or 7. This must be 2 through 6. This can't be 8, so this must be 9, which makes this 8. So again, 8 cannot be here. 8 has to be one of these 3 digits on this renban because this renban needs an 8, and 8 cannot be here or here. Therefore, 8's one of these 2 digits here. This cannot be... These 2 digits add up to 10, with no 9, 8, or 7, so it must be a 4-6 pair. That eliminates 4 and 6 in the rest of the box and row, so this can't be 6, this can't be 3. This can no longer be... Can't be 2, 7, can't be 3, 6, can't be 4, 5, because of the 2 in the box, the 4 and the 6 pair in the column. So this must be 1 and 8. Which eliminates 1 and 8 in the column 7. And this can't be 1 or 8. So this is 3. That makes this 6. This 4-6 pair eliminates 4 and 6 here. So it's 5 and 7. This can't be 3 in this box. This can't be 2, 4, or 6. So it's 1 or 5 here. This is odd. This is odd. These are even. This is odd. We have even there. So again, these must be 2 through 6 here. In row 1. No 3, 4, or 6 remaining in column 7. No 6 here because of 6 in the column. No 4 in any of those cells there, because we have a 4, 7 surrounding this quad clue. So where's the 4 in row 1? Can't be here. It has to be here. So this is 4, which eliminates 4 here. So that's 2 and 4. 4 is eliminated now in all of column 1 except for one cell. It has to be here. So this is 4. That eliminates 4 here. This is even. Remaining digits of column 7. We have 2, 5, 7, and 9 as possibilities. This one here eliminates 1 on the diagonal, so this is 8, which makes this 1. This can't be 1 anymore here. Remaining digits in box 3 are 1, 2, 3, 5. This cannot be 3 because of 3 in the diagonal. So, where is 3 in box 3? It has to be one of these 2 digits. This can't be 2 because of 2 on the column. Okay. Remaining digits of row 5 are 1, 5, 7, 8, 9. Okay. We know in column 7, 9 has to be one of these 2 digits here. This can't be 9 here. This can't be 1, 8, or 9 because of 1, 8, or 9 on the negative diagonal here. Can't be 7 because of 7 on the positive diagonal here. So this must be 5. So this is 5, which eliminates 5 here, so it's 1. Therefore, there's no 1, 5 here, no 1, 5 here, no 5 or 6 here. This 5 eliminates 5 on the positive diagonal, so this can't be 5. This is 1, which eliminates 1 in the rest of the box. This 1 eliminates 1 in the rest of the column. 4 eliminates 4 in the rest of the row. 5 has to be surrounding this quad, but it can't be here or here because of this 5 here. So that leaves this as a 5, which eliminates 5 from being there. 8 cannot appear in row 7 because of the 8 here. So where is the 8 in surrounding this quad? It has to be here. So 8 has to be one of those 2, which eliminates 8 in the box and 8 in the row. So this can't be 8, that can't be 8. 5 here eliminates 5 there. Okay, remaining digits in box 7. We have 5 through 9. This can't be 5 or 8. No 5 or 8 here, no 5 here, and no 8 here. So we have a 6, 7, 9 triplet in box 7. We can't have 5, 8 because of the 5, 8 here. We can't have 5 along this diagonal. We can't have 8 here because of 8 in the column. Therefore, this must be a 5, 8 pair. Okay. We have that one, so that's done. 8 we know is one of those two, so that's done. 8 is one of those two. 4 and 7 are surrounding here. This 5 eliminates 5 in the rest of the box. This can't be 6 because of 6 in the column. So we know one of these two digits is a 6 here. Remaining digits in box 9, we have 3, 4, 5, 6, 7. This cannot be 5 because of 5 in the column. Or sorry, 5 on the diagonal. This can't be 5 because of 5 in the row. No 4 either because of 4 in the row. We have a 3, 6, 7, 9 quadruplet in row 7, which eliminates 3, 6, 7, 9 in the rest of the row. So this is guaranteed to be 9 here, which means this can't be 9. Oh, this 7 along this diagonal eliminates 7 on the rest of the diagonal. So this must be 6 here. This must be 9 here, and this can't be 6 or 9, it's 7. Which eliminates 7 here. That eliminates 3, that makes this a 3, 6 pair, which eliminates 3 and 6 in the rest of the box. We have a 1, 2 pair now left in row 7. What else do we have? Okay. 3 has to be one of these 3 digits here. 3 must be one of these 2 digits here in row 2. Because there's no other place for it. It can't be here because it has to have a 3 in one of these 3 spots there. This can't be 5 anymore because of 5 in the column. And we have to have a 3, cannot have a 3 here because of the way that's filled out. Okay, this 6 eliminates 6 here, so that's 4, which makes this 6. That means remaining digits on the positive diagonal are 2 and 8 cannot be here, so 8 has to be here. So this is 8, which forces this to be 2. That means this can't be 8 anymore. Where is the 2 then on the negative diagonal? Can't be here because of the 2 in the box, can't be here because of 2 in the box, can't be here because of 2 in the column, and this is already guaranteed to be 1, so this is 2, which forces this not to be 2, that's a 3. Well, where is 3 on the negative diagonal here? It can't be here because of 3 in the box, can't be here because of the 3, 6 pair in the box, so it must be one of these two. We also can't have 6 on the negative diagonal here because of the 6 in the box. Can't be here because of the 3, 6 pair in the box, and these are filled out, so this has to be 6 here. Which eliminates 6 in these cells here. And we have 3, 4, and 7 remaining on the negative diagonal, with one of these digits being a 3. Okay. Remaining digit in column 3 is a 7. So that eliminates 7 in the rest of the row. And box, so no 7 there. We have 5, 7, 9 remaining in box 1, and this can't be 7 because of 7 in the column. Okay. The remaining digits in column 2 are 3, 5, and 9. Okay. Remaining digits... This 2 eliminates 2 here. So this is 3. Which means none of the rest of these can be 3 because 3 in the box. This can't be 3 because 3 in the column, so this is 4, which means this can't be 4, that's 7. That means the 4 eliminates 4 and 7, eliminate 4 and 7 here, so it's 3, which means this can't be 3. We have a 5, 9 pair in column 2, which eliminates 5 and 9 in the rest of the column, so this can't be 5 or 9, it's 3. 7 here eliminates 7 here, so it's 5, which eliminates 5 here, so it's 4. 5 eliminates 5 here, so it's 8 and 5, which eliminates 8 in the rest of the row. So this is a 4, 6, 7 triplet, which eliminates 4, 6, 7 in the rest of the box. So this has to be 3, 8, 9 remaining. 3 and 8 cannot be here because of 3, 8 in the column. So that's 9. This can't be 3 or 9, so that's 8, which makes this 3. 9 eliminates 9 here, so it's 7, which eliminates 7 here, so that's 8. Which eliminates 8 here, so it's 9, which eliminates 9 in the rest of the column. So we have now a 5, 7 pair, which eliminates 5 and 7 in the rest of the column. So this can't be 5. It's 6. This can't be 5 or 6. It's 8 and 9 eliminates 9 here, so it's 5. Which eliminates 5 here, so that's 9. This 4 eliminates 4 in the rest of the column. So no 4 here, no 4 here. This 5 eliminates 5 in the rest of the row, and it can't be 2 with a 2 there. So this can't be 2 or 5, it's 6, which makes this not 6, that's 3. So this can't be 3 here. That leaves a 2 and a 5 remaining in column 9. And we have a 2, 5 pair in box 3. That eliminates 2 and 5 in the rest of the box, so this can't be 2 or 5. It's 3, which eliminates 3 here, so it's 6. We have a 1, 9 pair remaining in box 5. That eliminates 1 and 9 in the rest of the column, so this can't be 1. That's 2, which makes this 1. 2 eliminates 2 here, so that's 6. So this cannot be 6 here. There's no 6 here. Where is the 6 in box 8? It has to be here. So, remaining digits in column 4, we have to have 2, 5, and 4. Well, 4 can't be here, and 4 can't be here, so where's the 4? It has to be here. So this must be 2 or 5. We have a 2, 5 pair in row 3, which eliminates 2 and 5 in the rest of the row. This can't be 5. That makes this 7, which makes this 5. So where is the 7 surrounding this quad? It must be one of these two cells. This 4 eliminates 4 here, so it's 7, which makes this 4. Remaining digits of row 4. We have 4, 7, and 9. 4 cannot be here because of 4 in the box. 4 cannot be here because of 4 in the box. Or 4 in the column, so 4 has to be here. That leaves this digit as a 5, which eliminates 5 in the rest of the box. So this is 2. This can't be 2 or 5. It's 9, which makes this 7. 2 eliminates 2 here, so it's 5, which makes this 2, which makes that 5, which makes that 2. This again has to be 1 and 9, and can't be 1 because of 1 in the row, so it's 9 and 1. That leaves this as a 7, 8 pair. 8 cannot be here because of 8 in the row, so it's 7, that's 8, which leaves this as 1 and this as 9. And that's the solution to this 4-player crazy Pong. We've got all these, you got the Pong things here. I don't know what the circles are. We have the white circles being the dots being knocked around. But yeah, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.